All right, so this mini lecture is going to look at yet another one of our electrical components when we're dealing with circuits. And we said that in order for current to flow in a circuit, it has to have a potential difference, right? The charges have to have a motivation in order for them to flow through a circuit. That potential difference we called a voltage. We learned about that as a voltage. And so this mini lecture is just going to talk very briefly about the sources of that voltage. We also call this source the electromotive, moving electrons, the electromotive force, or an EMF. And we sometimes see that as this kind of curly QE, all right? So the voltage source is the motivator for those electrons to move in that continuous loop of conductors. We often are going to talk about it as a battery. So a battery is a source of potential difference. In a circuit, the electromotive force, the voltage, is shown by one long line and one short line. The long line represents the high potential side. The short line represents the low potential side. Remember, in a potential difference, one area, one plate, when we talked about it in our voltage discussion or potential difference discussion, if you haven't seen that, go check that video out. One plate is at a higher potential than another plate, okay? And in a battery, that is designated by convention that the longer line is the smaller line. Further, by convention and in simple circuits, current flows in the direction from high to low. So we talk about current flowing away from the high side of a battery and towards the low side of a battery. So current goes out of a battery, or at the point of a battery, it flows away from the battery, and it goes in as it flows towards the battery. Now, you saw me do that in air quotes, right? Out or in. The current doesn't come out of the battery. The current is those free electrons that are in the wire. But the direction of flow is the direction away from the battery or towards the battery. All right. So a couple more things it's important to understand. I just want to make sure that in our description of circuits, we're going to really kind of look at ideal sources of voltage. So when I say a battery is 5 volts, we're going to get 5 volts of a potential difference. But in the real world, that's not always the case. Even batteries have a level of resistance. So if you haven't learned about resistance, yeah, go check out that resistor video. But the resistance within a battery is what we call the internal resistance. And it causes a slight difference in the amount of voltage that exists in the circuit, okay? And so it does then affect the current, as we're going to see in the video a little bit later on how current and resistance and voltage are all related. So it's not something to be sort of concerned about, but I do want to make you aware of it, that even batteries have some internal resistance that reduces the voltage throughout the entire circuit. For our purposes, when we say that a battery has 5 volts, for example, we're going to use that absolute ideal case. All right, that's it on voltages, and we're going to see how voltages, resistors, and currents are all related together, and keep going into our dive of electricity. Good job.